Okay, so today we're going to talk about functions and non-functions. So, like many things in math, there's very specific rules or characteristics that must exist in order for something to be considered a function. And if it's not a function, it's considered a non-function. There's actually a specific name to describe that as well that we're going to get to in just a second. So let's start with functions, and we're going to do kind of comparison side by side. So in order to be considered a function, each member of the domain, and remember, domains that's about the coordinate value x, must be paired with only one member of the range. Okay, so each x, so if I have an x of 2, it can be paired with 3, but it cannot also be paired with 4. Okay, so the range number can be the same over and over. So I can have a domain of 2 paired with a range of 4, and a domain of 3 paired with a range of 4. So non-functions, we actually call them relations. Because when we're talking about coordinate graphing and there's a coordinate point involved in x and y, there's some type of relationship trying to be displayed between the x and the y. And whether it's a functional relationship or a non-functional relationship, it's still a relationship. So that's why we call them relations. Make sure I did not spell that right. Ion, relations. Where at least one member of the domain is paired with more than one member of the range. So just like anything else, when we talk about squares, for example, squares are members of the rectangle family, and rectangles are members of the parallelogram family, and parallelograms are members of the quadrilateral family. Or when we talked about real numbers, we had real numbers, and inside real numbers, there were rational numbers and irrational numbers. Then inside rational numbers, there were integers, whole numbers, and counting numbers. So it's kind of like each characteristics kind of like made that smaller. And that's the same thing here. So if we drew this out, I'm going to draw this out with the shape real quick. Inside of this shape, we can say that exist all relations. Right, so all relations exist within this box. And then inside of relations, we have functions. And we have non-functions. So the difference being in this case is that in functions, each member of the domain will be paired with only one member of the range, and non-functions will have one member of the domain paired with more than one member of the range. But overall, they're all relations. Okay? So next we're going to talk about the four ways we often represent these relationships. So when we look at the 4 ways we represent these relationships, 3 of them you're probably pretty familiar with. this next one is probably going to be new for you, and it's called a mapping. And a mapping is a representative of a relationship. I'm switching here. The one arrow is used to determine if a mapping represents a function. So what does that look like? Well, with a mapping, we have two boxes, and oftentimes they look like ovals, and one represents the domain or the x values. We can make that a little bit smaller so it'll fit. Okay, so domain x just does not want to do it right for me. There we go, the domain x. And the range y. So one box is going to have all of our elements of the domain. The other box will have all our elements of the y. The thing that's a little bit different about a mapping than, say, a table or even coordinate pairs is that each member of the domain will only be listed once in the mapping, even if it exists more than once in coordinate pairs. Same with the range. Okay? And with this, each domain, in order to be a function, can only be paired with one member of the range. So let's say we have -1, 0, 1, and 2. And these are all members of the domain. And then over in the range, maybe we only have the answers 2, 4, and 6. You might say, but how would this make coordinate pairs? Well, because we're going to use an arrow, that's why it's called the one arrow test, to determine where or what matches up with each. So if the coordinate point was -1, 6, I would take an arrow from -1 and I would bring it over to 6. Arrow's just a little bit off here. So I would know that these two are connected together. Of course, if you don't get these arrows perfect, I'm pain to begin with. Okay, well, it's matched with 4. We'll go with that. And then say 0 matches with 6. And I'm going to keep on matching them up. And we're going to say that 1 matches with 2. Okay, I don't want this one. Trials and tribulations of tax people. And lastly, we're going to say that 2 also matches with 4. So you'll notice that each one of the domain elements only has one arrow exiting from it. And this arrow here kind of got a little shortened. Hopefully we can extend it. Okay. So each element of the domain only has one arrow exiting its number. Now on the other side, we do have a number, and we'll see what it points out mostly. We can say 2 or 4 that have more than one arrow pointing to it. And that's okay, because what we're worried about is the domain. Each member of the domain can only be pointing at one number over here. Now on the other side, we can say this is going to be a little bit smaller. Say we have a domain of 1, 2, and 3. And maybe our range can be 1, 2, 3, 2, 3, and 4. Just a little bit smaller. Just expand it outside of its box a little bit. And our arrows, we're going to say 1 matches with 1. Actually, I'll just move that down. 1 matches with 2. And 2 matches with 1. Actually, I'll just move that down. We'll say 3 matches with 1. That's fine. Okay. And 2 matches with 4. And then we're also going to say that 2 matches with 3. Okay, so when we look over here at the domain, we can see that 1 has 1 arrow pointing out of it. 2, unfortunately, has 2 arrows pointing out of it. And 3 has 1. Because remember, everything in math is also opposite. So if this over here, I guess we have to put these in here, domain, and range, right? And this is a mapping is a representative of a relationship in a non-function more than one arrow is coming from at least one element of the domain. Okay, so this is how we have opposites. They're both mappings. In this one, the one arrow test is met because each member of the domain has one arrow leading from it. Here, the one arrow test is not met, meaning we failed the one arrow test because the domain element 2 has two arrows coming out of it. Okay, so that is what we look at in terms of a mapping. Moving on, when we look at tables, what's known as the X no repeats or no repeat test is used to determine if a table is a function. So here, when I'm looking at a table, I'm not concerned with the values that are representing the y coordinates at all to determine if it's a function. I simply look at the x coordinates, and I have a -1, a 0, a 1, and a 2. And none of them are repeating. None of them are identical, so therefore, this table represents a function. So in a non-function, the opposite, at least one element of the domain is repeating. Not sure what I was going to write here. In a non-function, at least one element of the domain is repeating and has, actually, we don't need anything else. We can just say is repeating. So I'll take the rest of the stuff off. So for example, if we had -1, 0, 1, 1. Oh, I know now. It has a different output. So here, if I had 1, 2, 3, 4. So here, the 1 is repeating, and they have different ranges. So that means you have an element that has more than one output associated with it. If I had just repeated the same exact coordinate pair, if it said 1, 3, 1, 3, where it's basically identical, then it would still be a function. But when it's listed more than once and they have different outputs, it makes it a non-function. So typically, all you do is look at the x values in a table, and because you're not going to write a repeating coordinate point in a table. And if each x is different, like over here, you're a function. Over here, when they have a repeat, it's not a function. And then graphing, the third representative of the relationship that we're looking at. So the vertical line test is used to determine if a graph is a function. And vertical, remember, means up and down. So what we're looking for is we're going to look at each one of the vertical lines in a graph and make sure that at no point do we touch the graph more than once. So for example, if we're looking at a line, that's going to be a function because we're only touching it once, right? And that could be a straight line. Maybe we have a V, right? So maybe another example could be, see if they let me put it on here. Say I have a line going this way, and then I have a line going this way. That would be okay. And this line would be okay. Some examples of non-function. So in a non-function, at least one of the vertical lines on the graph, keeps on putting me in the wrong box, driving me crazy, on the graph has more than one coordinate point. So imagine if we took this V that's facing upwards and we made it face sideways. So here, this would be a non-function because I can clearly see that if I looked at just this axis, it would have a point here and a point here. If I looked here, it has 2 points, right? So I would not be able to pass the vertical line test. And I mentioned there was 4 ways that you can represent a relationship. And of course, the last one is just by using coordinate pairs, right? So if you just had people say, here's a bunch of coordinate pairs, that would be a relationship. So to reiterate, going back to the beginning again, we have functions and non-functions. They both are considered relations. Usually we just call non-functions. We don't go around calling them, that's a non-function. We just call it a relation, right? And within relations, in order to be a function, you have to meet these guidelines. You have to have each member of your domain only paired with one member of your range. If we're given a representative of the relationship, there are different tests that we're going to use to determine if it is a function. If we're dealing with a mapping, we're going to use the one arrow test. We're going to look at each member of the domain, and as long as they only have one arrow coming from them, it is a function. When we look at a table, we're going to look at the x coordinates. As long as none of them are repeating, it is a function. If one of them is repeating and they have the same exact output, then it's okay, but that would be silly. Why would we write the same coordinate point twice? So just focus on the x coordinates. None of them repeat. Your table's a function. Then the vertical line test. We're going to look at each vertical line on the graph, and as long as that each vertical line can have no more than 1 point on it. So here you can see 2 points. Remember, these were 2 separate examples of functions. If we put this together, no, they wouldn't be a function. But this line is a function, and this V is a function. Because in both examples, only 1 point exists on the vertical lines of the graph. And that is how you tell the difference between a function and a relationship that is not a function. Okay, so to finish out, you're going to have 2 GPs. One is GP9. It's right here on this page. And I don't think it's on there yet, but I'll write it on here at the top. This is GP10. You're determining if things are a function.